Hello everyone. Today, we're focusing on space in Einstein's relativity. We often think of space as just a location, but in relativity, it's much more than that. Let's explore why space is so important. In relativity theory, space and time come together as a unified entity called spacetime. This spacetime can be warped by objects and gravity. What does that mean? It's a fresh perspective. This unification is known as the spacetime continuum. Space and time don't exist separately, they influence each other. So, how does space actually change? When an object moves at high speeds, the space along its direction of motion contracts. This is called Lorentz contraction. To an object moving close to the speed of light, space appears compressed, and distances seem shorter. This shows the relationship between speed and space. Next, let's talk about how gravity affects space. In the 17th century, Isaac Newton explained gravity as the force that pulls objects toward each other. His law stated that objects with mass exert gravitational force over a distance, which was seen as an invisible force. However, Einstein described gravity as the warping of spacetime. Massive objects bend spacetime, and this curved space pulls other objects toward them. In other words, gravity is a force that distorts space itself. This is called general relativity. For example, around massive objects, space bends, and objects move along that curved space. So, gravity arises from the warping of space. A black hole is a place where the warping of space reaches its extreme. The powerful gravity of a black hole stretches the surrounding space to an extreme degree. This phenomenon is sometimes called spaghettification. If you get close to a black hole, space becomes infinitely distorted, and nothing can escape from it. The warping of space also affects the path of light, a phenomenon known as gravitational lensing. When a massive object bends the space around it, the light passing near it bends as well. For example, light from a distant star can be bent by a large object, causing us to see the star in a different position than where it actually is. On a larger scale, space isn't just bending, it's expanding. The universe, which started with the Big Bang, continues to expand. This means that space itself is stretching. We don't know what lies beyond the observable universe, but the range of what we can see is constantly changing. The expansion of space also affects time. Light from distant galaxies appears red due to a phenomenon called redshift, which happens as space expands and stretches the wavelength of the light. As a result, galaxies far away might seem to experience time more slowly. Again, we see how closely space and time are intertwined. Even on Earth, there's a slight warping of space. While Earth's gravity is relatively weak, it still causes a small distortion in space. At higher altitudes, where gravity is slightly weaker, space is slightly different, which also causes time to run a little slower. This shows how space and time are connected even in our everyday lives. Today, we explored the concept of space in the theory of relativity. Space isn't just an empty place, it bends and stretches depending on speed and gravity. Understanding the warping of space is key to understanding our universe. Next time, we'll dive deeper into other aspects of relativity. Thanks for watching.